All right, so here is the 7.2 notes that we'll be dealing with. There it is. That we'll be dealing with exponent properties involving quotients. As we did in the last section, we did exponent properties involving products. Now this will be dealing with exponent properties involving quotients, which basically is fractions, division, all that kind of stuff. Okay, so there's one way I'll kind of show you, and then there's kind of the logic way I like to show people. So the first example, let's just do brute force. Let's just draw out, what this is telling us. So I have 2 to the 10th power over 2 to the 7th power. So that usually means what I do is I do 2 times 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 2 again. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 twos. And I'll do the same thing on the bottom with 7 twos. All right. 1, 2, 3, 4, 5, 6, 7, 7. Okay. So now what we do here with this is anything that I have on both top and bottom of a fraction that is similar. So essentially, if I have a 2 on the top and a 2 on the bottom being multiplied, I can cancel those out. And I can cancel those out, cancel out, cancel out, cancel out, cancel out. If I can't, and then once I run out of stuff on the bottom to cancel out, all I'm left with on the top are these 3 2's right here. So now it becomes 2 to the 3rd power, which again is equal to the number 8. Now, that's kind of the brute force way of dealing with it. Now again, let's take a look at the logic side of it. So from the last chapter, or the last section, we were learning that if you multiply these bases out here, well, all you do is just add those exponents there. So let's do a little bit of English stuff here. Multiply is to add. Well, what if we're dividing? Because this is technically what this is. This is 2 to the 10th power divided by 2 to the 7th power. What if we divide? Well, if we're thinking about this logically, multiply is to add, as divide is to subtract. So that's what it is. Because again, and then even look at the example. 2 to the 10th power over 2 to the 7th power. Well, we got 2 to the 3rd power. 10 minus 7 equals 3. Look at that. And again, if we do the same thing here, y to the 7th, y to the 7th over y to the 4th. Cancel my, went too far. Cancel my y's out. I'm left with 3 y's, y to the 3rd power. Okay, look at my exponents here. 7 minus 4 equals 3, okay? So again, when we're dividing the bases of exponents, all right, we just subtract the numbers, all right? Again, it's the same. It's honestly a lot of the same logic as what we did with multiplying, except instead of multiplying, now we're dividing. So, but either way, all you're either doing with those exponents is adding or subtracting, and we'll also get into when you multiply them as well. Okay, so let's deal with this. So I got example number 3 here. I got 8, a to the 5th, b to the 4 on the top, and then 28, a to the a cubed, and b squared on bottom. I'm going to worry about the exponents first. I'll come back to this 28 and 8 right there. So let's worry about these first. A to the 5th power over a to the 3rd power. Again, I got 5 over 3, so I'm just going to do 5 minus 3. We're going to subtract these exponents. So it's going to turn into a to the 5th minus 3, which turns into a squared. B to the 4th power over b squared, which means that turns into 4 minus 2, which again just equals 2. So it's going to be b squared. So let's kind of start setting up our final answer here. So we know we're going to have a squared and b squared, okay? Now, what that means is that these numbers on the bottom go away, and all we're left with is just a squared and b squared on the top of the fractions, all right? So anytime that we're doing this, anytime that we're subtracting these exponents, our final answer is always going to end on the top of the fraction. Now, the next section we'll learn when it doesn't, but for this section and what we're doing right now, all of our exponents will end, all of our variables with exponents that we're subtracting will end on the top. Now, what we do with this 8 and the 28, we basically rip it out on its own and treat it like its own fraction. And then from there, as we've done with all fractions, we just simplify it out. And what I can do, I can divide both the top number and the bottom number by 4. 8 divided by 4 gets me 2. 8 divided by 4 gets me 7. Now, when I put this in my final answer, I just kind of, okay, so the 2 is on the top, so it's going to go on the top of the fraction. The 7 still remains on the bottom of the fraction with nothing else down there because, again, we've canceled out these a's right here. So that's all that I am left with there is 2a to the a squared, b squared over 7. All right. All right, so let's go and do another example here. So now we have a 5x over 2 to the 4th power. All right, and if we recall in the last section there, if we had a exponent raised to multiple bases, we distributed that exponent to all of the bases, and it became 5 cubed x3, and that kind of thing. This one is the same thing. We're going to take this exponent here and distribute it to all the bases. But remember, now with dealing with fractions, we not only have a top to distribute to, we also have a bottom. So we're going to distribute the 4 to the top parts of the fraction. That gets me 5 to the 4th power and x to the 4th power over 2, distribute that 4 down here, 2 to the 4th power. Okay? And then from there, we're going to try and simplify it out further. Again, I have different bases here, the 5 and the 2. I'm looking at the bases to see if I can subtract or not. I can't because this 5 and this 2 are not the same. But from what I can do is I can find out what 5 to the 4th power is without the exponent, and same with 2 to the 4th power. And if I do that, we will find out that 5 to the 4th power is just 625. X to the 4 stays the same, and 16. X to the 4, we can't do anything more with that. There's nothing on the bottom here that I can simplify that out with, so x to the 4 will stay the same. And 625 over 16 as a fraction will not simplify out any further, so that is going to be our final answer there, okay? Example number 5 here, all right? Same as what I did up here. I'm going to start by distributing this 3 to all of my bases here, down to here, down to here. And if we do that, we're going to get, let's see, 4, distribute that 3 there, gets me 4 to the 3rd power. X to the 5th to the 3rd power, that's just 5x to the 5 times 3, which turns into x to the 15. And then that'll be y to the 3rd over, and to the bottom, x to the 3rd, and then y to the 3rd, all right? Now, I'm going to go ahead and simplify out that 4 to the 3rd power, which is 64. Let's see, x to the 15, y to the 3rd, still on top, over x cubed, y cubed. Let's see, 64, there's nothing on the bottom here that I can simplify that out with, so 64 is going to remain the same. X to the 15th, I have an x on the bottom that I can simplify that out with, so if it's x to the 15 over x cubed, I'm going to subtract x to the 15, so it's going to turn into x to the 15 minus 3. So I'm going to rewrite it down here, which turns into x to the 12th power, which then cancels that out on the bottom, turns into x to the 12th power on the top of my fraction. And then I got y to the 3rd power over y to the 3rd power. Now that turns into y to 3 minus 3, but what we could also look at is it's literally the same thing. They're the same exponents, 3 and 3, with the same bases on top and bottom. So I can literally just cancel those out. I don't even have to do anything further with that. I don't have to write any y's down. We just cancel them out. So it's y to the 3rd over y to the 3rd again. Same exponents, same bases, they just cancel out. So all I'm left with now is 64 x to the 12th power. That's all I can do with that. Now example number 6 here. I have 2x to the 4th power times 9x to the 8th power, all that squared, and then over 3x to the 7th power. Now this is one where you have to be really careful about, because that's how a lot of people messing up on this are making this mistake where they distributed this 2 out, and they distributed the top out, and I'll go ahead and do that. 2 squared, x to the 4 to the 2nd, that's just 4 times 2, which is x to the 8th, times 9 squared, and then x to the 8th to the 2nd, which turns into 8 times 2, which is x to the 16th. But what I saw was a lot of people taking this 2 to the bottom here, all right? Now, the way that this is set up, the parentheses are only on the top here, okay? They're only on the top here. They're not surrounded by the entire parenthesis, all right? If it was, in these examples here, you see that the entire fraction is surrounded by the parentheses. In this example, only the top is surrounded by the parentheses. So if you only see the parentheses on the top, you only distribute it to the top part. And it's same with the bottom. If you had parentheses around the bottom here, you would only distribute it to the bottom here. So that 3x to the 7 is going to remain the same, okay? And then from there, let's go ahead and simplify out the top. And we would do this as we did last chapter, right? We would, see if, if we're multiplying this top here, we're multiplying bases, we'd find similar bases and then add those exponents. Now, for my numbers, I don't have similar bases. The 2 and the 9 are not the same. So what I can do is I can just find out what those numbers are, without the exponents. So 2 to the squared is 4, 9 squared is 81. I'm just going to rewrite the x to the 8th, 81 to the x to the 16th. Oh, excuse me. And then from there, what I can do is then just multiply those numbers out there. And then 4 times 81, let me get a calculator out real quick here. Gets to me 324. And I'm going to bring that over here, 324. I'm going to kind of move it over here now. And then x to the 8th, and then x to the 16th. We're multiplying those variables again. So we're going to add the exponents. So I'm going to do x, and then it's 8 plus 16, which gets me 24. And that's still over 3x to the 7th power. That 3x to the 7th power, gosh darn it, 3x to the 7th power has not changed, okay? All right, now it has turned into, oh my goodness. Now it's turned into a division problem where I can, and I'm actually going to write the final answer kind of up here when I do this. I got the x to the 24 over x to the 7th. And again, I got my similar bases, so what I'm going to go ahead and do is just subtract those exponents. So it turns into 24 minus 7, which turns into x to the 17th power, which gets rid of the 7, which gets rid of the fraction, moves it to the top of the fraction. And then if we do 324 over 3 as a fraction, well, we could also even do 324 divided by 3. That just gets me 108. Technically 108 over 1, but if we have it over 1, we don't even have to write it out, so it just turns into 108 x to the 17th power, okay? All right, so those were the video notes for section 7.2a. I will get the 7.2b notes up here very soon. Thank you.